Hello and a warm welcome from our side to our fourth session from our DATRON Digital Experience Days 2020. In the last few days we had a focus more on the milling machines, and today we would switch to the additive world and show you something about our volumetric dispensing systems. First of all, we would like to start to introduce ourselves. My name is Dirk Iller. I'm working in the dispensing field and responsible for sales and for project management. And my colleague?
My name is Lukas Negede. I am responsible for the application in dispensing area. So.
Okay, and at the end there are a lot of different kind of dispensing technologies and different kind of applications. And to give you a first idea, what is our focus? We would like to show you some samples and discuss some specific things and advantages of our dispensing technology. We'll move to our application table, and at the end we can divide these different kind of applications into 4 different kind of areas. We talk about gluing applications, about gasketing applications, we talk about EMI shielding and heat treatment, and the last one is potting and dam and fill. And I guess we start with
the glue application. So for this case I will show you a sample part. So on this sample part we have a glue process. That means for the glue process we need 2 parts. One is the cover or the frame, and the second one is in this example a glass plate. This can be a screen display or touch screen. And the application itself is we need to place the aluminum frame into the machine, start the program and dispense a material. This can be a silicone or silicone-free material, a glue. Afterwards we join the glass plate or the display, touch screen, etc. to the aluminum frame and material, and this will cure directly on the part. So that means after we are dispensing and put both parts together, this needs to be placed somewhere to cure the product. With this kind of technology we have 2 advantages. So one is the glue of 2 materials, which is glass and aluminum, and the second issue is with sealing effect. So when it's glued, and then you have directly a sealing issue with the material, with the silicone, so that you have a highly IP classification on that purpose, and there's like protection of dust or water or fluid stuff for the electronic cover. So we have a second example. This one is a small display where the frame was placed on the machine. We are starting to dispense. Afterwards, the glass will be placed into the fluid material, into the silicone, and glue together the glass with aluminum. And we have a sealing effect, and then this is also a visually positions. That's why it needs to be an accurate dispensing system to use that. And we are confident and sure to show you this kind of application on our machine. So okay, the
next one is gasketing, and I guess this is a part which maybe somebody of you saw already in the last days in our milling session, 5-axis milling session. It's a motor block. And maybe Lukas, you can give us some more information about that.
Yes, this part was milled on the DATRON milling machine, and afterwards we put the gasket, the silicone gasket, on the motor block. And it's not only this part. We have another electronic housing where we placed, where we are milled firstly the material, the aluminum part on the milling machine, and then dispensing the bead on the part, the gasket. So you can see here we have the control with radius, and the machine is dispensing accurately all over the area. We have the constant volume, and the start stop is the main point of gasketing, and which is here at this area where you can see our ramping and the start stop position, which is made perfectly. And this is our main or core business to yeah.
But I guess, which is also interesting in the time of e-mobility, is I guess these fuel cells application.
So this fuel cell product was also milled. The graphite part was milled on the DATRON milling machine. Afterwards, the part was cleaned, and then we dispense a gasket directly on the fuel cell. And this is a new technology for us also, where we are have a lot of projects and contacts at the moment, and this will be the future.
Okay, next one I guess is EMI shielding.
So the next samples are showing you the functional of applications, which are which have the two kind of applications. So one is the gasketing issue. The second one is they have a function. That means this part is, for example, EMI shielding. The gasket has one is like a gasket. The second application is to shield or to have a protection of electromagnetic frequency. So the same functional or protection applications are here with a board where we are dispensing a bead, like a dam. After we put the dam, we fill the area with a fluid material to have a protection, 100% protection to the electronic parts. Another example here, this area, this is also a dam and fill, where we are protecting firstly with the dam, the connector here around, and then filling the board with fluid material.
Okay, I guess that's all. Did we talk about the combi dispensing?
Yes, here we have a combi dispensing. This is a DATRON specialty, where we have the EMI material and silicon together. The core of the EMI, the gasket is a silicon, and the EMI material is outside, or the cover. And this cover is the functional part, the EMI shielding parts, and inside, what is happening inside, it doesn't matter. With this technology, we have the possibility to get a softer gasket. Additional, the second advantage is we reduce the cost of the EMI material, which is very expensive. So, and the shielding is happening only on the cover of the gasket. So we are saving material and we get a softer gasket.
Okay, I guess that's all for now. Then we would like to switch into to show it to you live. For that, we use this kind of electronic housing. So we prepare this outline on the machine, and we will start with that. And Lucas will show us the process, starting from changing the needle and then to dispense the part.
Yes. So we have here standard needles on the market, which are plastic needles. This is the needle, the tip what we are using for our tools for dispensing the material. Now I will show you how we exchange this needle, the tip, and measure it. This is a plastic needle, so that they have a bigger tolerance. So we need to measure the length and the position of the needle in X and Y direction to have a good process in our application. So here we have a lock adapter. We just remove the needle like this, the old one, put a new needle, and run the program, execute the needle measurement program. The machine is moving to the position, measure firstly in Z direction, the length. So with the light barriers in Y and X direction, we are measuring the position of the needle. So now the machine knows exactly the position of the needle. So if you set some 0 point, this 0 point will be correct always after the measuring. So the next part is, now you see the needle is empty of material. We need to fill up the material. So we just purge material and let a little bit material out so that all air bubbles are out of the needle or out of the system. So we'll just switch off, so clean up the needle. Now the machine is ready to start up. So I will run now the contour from the electronic housing. So the main focus is on the start-stop point, and then when we are running the application, we are accelerating and decelerating on the corners. And even though the volume is still the same. So this is our core business and our advantage on the DATRON dispensing machines.
And the most critical point on each gasketing is always the start and stopping point. And for that we have a special function. You can see it here in this slide. So it's a kind of ramp function. So we start with less material and bring it up to the top, and then we move over the complete outline. And if you come back to the start and stopping point, we close the ramp, dispense less material, and so you have a very nice start and stopping point without any top on the top material at the end of the bead, which is very, very important for gasketing function, because there's always the same height over the complete part. And this kind of ramp function we would like to show you directly live on the part. For that we slow down, Lucas, the speed a little bit.
Yeah, we reduce the speed at the start point, that we can show you the ramping function. So I will execute the same macro again and reduce the start. There you can see ramp up of the machine at the beginning. So I will increase the speed inside the contour and reduce at the end again to show you the end joint point. So there you go, and we will get a perfect start-stop point.
Okay, maybe we can show it, put it up and show it directly in the camera. And what we now would like to show you is the most important part on the dispensing head is the pump. And mostly we use a kind of gear wheel pump. And this kind of gear wheel pump would like to show you so that you get a feeling how it works and how we can dispense in that quite good conditions. Okay, then we go back to our application table. And Lucas will give us some more information about the pump.
So we prepared here our gear pumps. So generally we have different kind of pumps. This kind of pumps we are choosing depending to your material and application. So we use today this gear wheel pump from DATRON. This is the aluminum cover. And here inside we placed 2 gears. So the gears can be placed like this. This is number 1. And then the second one. So the gears are in position now. We placed the cover on it. So, and there is an adapter. This is also an on-market standard adapter to connect the pump with a needle. So we just screw the adapter, put the needle, So now the pump is completely finished, prepared. And this is also the advantage of our pump. As you can see, it's very easy to assemble or disassemble. In case of cleaning issue, when you have a material which are, so we can disassemble easily. When you have a material which are cured under room temperature or moisture, this need to be cleaned every day. And if you have a simple pump where you can easily disassemble and clean, it's a big advantage for you in the new process. So when the material is finished, the pump is finished. There we have a cartridge, a material with a 300, in this case 310 milliliter cartridge. Adapter will be put, cartridge adapter, and put into the machine, and that's all what you have.
And what is the idea with the, I see that the gear wheels are made of plastic. What is the reason for that?
So we have, with this kind of pump, we can use high viscose material, which is very stable, and material with filler inside. So if we are using material with filler inside, the consumption of spare part we can reduce due to the plastic gear, and yeah, that's the big issue.
And then we have another one.
So we have a second type of pump. This is for fluid material, and this material is, or this pump can be used for high viscose material, which is without filler. So because the pump is very tight, and even a material with filler inside, with only fluid. So that means very fluid material like water. So the pump is very tight, so you can still dispense or use it for dam and fill material, for example, for fluid material. Okay. So, but we have additional to this different other kind of pump system, depending to the application, depending to the material, what the customer needs, what the application needs. We are choosing the pump as well as the dispensing head, and yeah. So we have a variation on this this type.
Okay. What I will show you on the next slide is what are the advantages, some are related to other dispensing systems. So we talk about our system is a volumetric system, and the standard systems are time pressure systems. That means you put some pressure on the cartridge, for example. The material flows out over, normally you have a valve at the end, and it's necessary that you have the same speed, the same pressure on the cartridge, and the same temperature, because if you have a higher temperature, then you have other viscosity and not the same dimension of the bead at the end. And all of these different functionalities we cover with our volumetric dispensing systems. That means we have a very constant bead all over the complete outline, independent of the speed, independent of the viscosity of the material, and also, as we said it before, very accurate start and stopping point. And I guess we have one more live application.
We have a second one. I will show you firstly the second application where we ramp up the volume with a constant speed, and then we will show you another application directly after that. So I will run a second application where we are moving a 200 millimeter long line with a constant speed, and we are changing during the movement the volume of the material. So I will execute it again so that you can see it better. So we are moving with 8 meters per minute in constant, and then changing the volume during the movement.
So that means if there are some applications, for example, from the electronic industry, where it's necessary to have more or less material on the bead, then it's possible to program it directly in this area where it's necessary.
Yeah, we can reduce or increase the amount of material defined in every area where we need it.
Okay.
Yeah?
And then we come back, I guess, with the third application.
Yes.
It's a kind of base station, the outline. And what we do
at the beginning is that we have a 3D probe to measure the height of the part, because at the end it's always the point to have a very nice height of the bead. You need a very, the same surface all over the part, and for that we can measure the part with a 3D probe, but also with an optical sensor. Both is possible, and we can show it to you directly here on the machine.
Okay, so now the next aluminum plate is placed on the machine table. On the right side of our dispensing head, we have our mechanical probe. We are measuring the surface with the probe and correct the height tolerance. And then afterwards, we are dispensing or place the gasket on it. So we are moving to the first point and then start to measure the surface. So now we are finished with the measuring. So the machine knows the overall surface height and then start to dispense. So we are dispensing very fast here, and as you see, we have some corners where the machine has to reduce the speed. And even though we have always everywhere the same amount of material, even when we are accelerating or decelerating at the same point, the volume is exactly the same. And then the good advantage of our machine is also to have a good connection in T-joints or where you have a start and stop points. Here you can see when we have a T-joint or when two paths are connected, there we have a good connection between both. Yeah. And all this is working with high speed. So this application is one from base station in the telecommunication area. Their material will be dispensed with EMI, like EMI shielding materials, and yeah. So generally the products are running 3 shifts, and with EMI shielding material, when the material is very abrasive, so when the gears are wear out, then you are exchanging easily the gears, and then you have almost no production stop.
Okay. Can you give us an idea for the cycle time of this part, including the...
So including the measurement is 2 minutes and 20 minutes. 2 minutes and 20 seconds, and excuse me. So the only dispensing part is around 1 minute and 30 seconds. Yeah. So here you can see the quality of the joining points, and even the volume at the corner. Everywhere looks perfect.
Okay, great. Then I guess if we come nearly to the end, we will discuss or inform you about some more accessories, what is possible with our machines to adapt on our machine. So maybe Lucas, you can give us some ideas.
So we already showed 2 accessories. One was the needle compensation unit to measure the needle and correct the tolerance of the needle. The second equipment we saw is the probe, the 3D probe, to measure the height, the surface of the part. And this is the probe, it's a mechanical probe. We can use, instead of the mechanical probe, a laser or optical sensor to measure the surface and correct, to reduce the cycle time in this case. And additionally, we can add a plasma head to clean or to clean the surface of plastic parts or aluminum. And this will be pre-dispensing, so that means pre-position of dispensing. Before dispensing, we are doing the surface treatment. Afterwards, we are dispensing the material to have a good adhesion on the surface, so between the material and the surface of the product. And we have double heads, two heads with two different kind of material, or the same material with double head, or additional equipments with, if you are not using cartridge for material supplying, they can be used pail from like pail pump for pail material supplying up to from 20 kilo up to 200 kilogram, and several kind of cartridge systems or supplying unit it can be adapted to the machine.
Okay.
Yeah.
And the last point, I guess, is the machine itself. So that means we have different kind of machining systems. I guess we started with the smallest one, something about 300.
240 by 300, the
Right.
small size, up to 1,600 to 3 meter. The machine, we have it in standalone or inline system. The standalone means the machine with the access system, table, and then the cover for the machine. So we have also here a light curtain to secure the area, from the working area and outside. And the inline system is without cover, only the access system which will be integrated to production lines. Yeah. So the access or the machine will be defined by production strategy of the customer. The quality of dispensing is when you are sampling on this machine or on the small machine, everywhere you will get the same quality of dispensing. The only issue how you choose the machine is whether you are dispensing inline or standalone for manual mode, or bigger size or small size for the application.
Okay, I guess that's all
So I think we have
For-
everything.
for today.
Yes.
So hopefully it was very interesting for you, and thanks that you joined us. It will be great if you can join us also tomorrow. Tomorrow we have the focus once again on the milling side. That means we talk about milling tools, and it will be great if you can join us there too. And in the end, thanks again, and see you. Bye.
Bye-bye.